Inversion of control is one of the most important patterns in object-oriented programming and forms the base of popular architectures like the Hexagonal, Onion, and Clean architecture. In this video, I'll answer these questions. What's inversion of control? How is it implemented in Spring? And why is it important for the great architectures? Let's start. Inversion of control is a design pattern that frees our classes from the responsibility of managing their dependencies and places it onto an external framework, such as Spring. But what's a dependency? A dependency is simply a reference to another class. For instance, a domain service class managing products needs a reference to the repository class to persist and retrieve data. The service class depends on the repository because it's unable to perform its functions without it. Developers often take for granted that these dependencies are resolved by a framework like Spring. But what would happen if we let each class control its construction instead of relying on a framework? Coupling would increase because rather than defining dependencies as interfaces, we need to reference one of their concrete implementations. This results in a loss of information hiding, the ability to conceal implementation details behind stable interfaces, making it difficult to change the implementation without all classes that depend on it. It's also more challenging to share instances across classes. Typically, database connection pools and clients are configured once and shared across the entire application as singletons. In a world without inversion of control, we are responsible for implementing the singleton pattern, and any error can cause duplicate instances and bugs. Now that we understand what inversion of control is and why it's important, let's see how Spring implements it. Spring implements a specialized form of inversion of control called dependency injection. Dependency injection is a pattern where objects declare their dependencies as configuration metadata, which is then processed by the framework to create a fully configured system. Spring supports configuration metadata in different formats. The most common today are annotations and configuration classes. However, it's also possible to define external XML files or Groovy scripts. The configuration metadata is parsed by the Spring Ioc Container and translated into bean definitions. A bean is simply an object that's created and managed by the framework. As you can see, there are several properties that characterize a bean. The most important ones are class, name, and scope. The class defines the type of bean, while the name is used to distinguish different instances of the same type. The scope determines the life cycle of the bean. If we want only one instance of a bean, like in the case of a database connection pool, we set the singleton scope, while if we want a new instance each time a bean is requested, we use the prototype scope. There are also more scopes and properties, but let's stick to the basics. If you want more details, leave me a comment and I'll cover them in another video. For now, let's have a closer look at the Spring Ioc Container. The Spring Ioc Container is characterized mainly by two concepts, the BeanFactory and the application context. The BeanFactory is the root interface responsible for instantiating, configuring, and managing beans. In a nutshell, it provides the basic dependency injection. The application context extends the BeanFactory and provides additional functionality that's needed to fully configure the application according to our needs. There are several implementations of the application context, designed to support different configuration formats and application types. If you are a young developer, most probably you never interacted directly with the application context, because you utilize instead Spring Boot. Spring Boot is yet another layer wrapping around the Ioc container that auto-configures the application context reducing the amount of configuration metadata we need to write. Sometimes, we just need to annotate our custom beans, while Spring Boot defaults are enough to configure database connections, authentication, authorization, messaging, and much more. In the past, we used to interact directly with the application context. I recall having to write all the configuration as multiple XML files and then load the application using the class path XML application context. It used to require some skill and a lot of patience. Anyway, let's move to the last question, which is, why is inversion of control important in the context of the great architectures? Without IOC, it's not possible to implement the popular great architectures because they all rely on the idea that the core business logic of the application should have no direct external dependencies, like UI, databases, or message queues. We can only comply with this requirement with proper information hiding. In simple words, we need to define a control flow where interactions with the application core are governed by interfaces. It's then the framework that is responsible to wire these dependencies at runtime. Without IOC, this is not possible, because we would reference concrete classes rather than interfaces. If you want to understand more about the great architectures, Onion, Hexagonal, and Clean architecture, I have a video covering each one of them. If you enjoyed the video and watched it till here, I just ask you to like, comment, and share so I can grow the channel and make sure that everyone can learn something new.